Good morning, all. We are about to start the event. Before we start, I request all the participants to please be on mute so that there is no disturbance while the session is going on. Thank you for your cooperation. So, good morning, all. And as you all might be aware, that we have organized CSIR Jigyasa Epic Hackathon. We have launched this on 5th of January 2024 for the school students. So to help out the students and to increase their culture of innovation, we are organizing these boot camps for the students. So today we are having our first boot camp, and I welcome all the distinguished panelists and hope that their talk will enable students to come up with the right kind of problem statements to be addressed. So welcome all. So to begin with this session, I would first like to call upon Dr. Parthasarathy Ramakrishnan, Principal Scientist from CSIR, Indian Institute of Toxicological Research, IITR. To brief about him, Dr. Partha earned his PhD from CLRI and University of Madras. He has more than 20 years of research experience in applied biochemistry to unravel important issues in human health and the environment. He has authored more than 118 research articles in highly reputed journals with 7,400 citations and 6 patents to his name. He has received several awards, including prestigious Craze HPC Dr. APJ Abdul Kalam Award in 2019 and the Young Associate of Indian Academy of Sciences in 2008. He was also elected Fellow to the Royal Society of Chemistry in 2020 and Indian Chemical Society in 2019. Currently, he is involved in the development of AI and machine learning-based computational toxicity models, biomolecular simulations, databases, and developing innovative predictive approaches relevant to translational research. Over to you, sir.
Thank you so much for a very nice introduction. And first of all, I welcome you all to our first boot camp of CSIR Jigyasa Epic Hackathon. And today we are having a really exciting and igniting start of today. So we have our Dr. K. Ramesha, Director, CSIR SICRI, going to talk about clean and green energy. And Dr. Sailaja Ma'am, Chief Scientist, IICT, going to talk about like more deep into science and technology innovation and entrepreneurship. And our good friend, Dr. Anshu from CSR Inter, going to talk about One Health. So I really welcome all of you for this first boot camp. To begin with, CSIR started this very inspiring path as a CSIR Jigyasa program in 2017 to have the students to come the first-hand experience in our CSIR laboratory, like what kind of research we are doing and how it started, how that is relevant to them, particularly everyday life. And it's not about like visiting the lab. So we thought of making this program into making science and technology development, which going to create the igniting curiosity and nurturing scientific temperament among school students. That's where this epic program that's called Empowering People, Innovation, Creativity, it started. It's like exactly is a testament to CSIR commitment to fostering a culture of innovation among school students. So we have started this EPIC program in 2017 with a small set of students. So we announced this call and people started applying their idea. It got selected and we thought inviting them, it's like not, it's a kind of a boot camp. They used to come and stay here in our lab with the mentorship of our scientists. They create that small innovation, whatever they propose as a small prototype, or sometimes they can also come up with the real products. So that's where it's all started. Now, with all our CSIR team efforts, it's coming to the another stage at the pan-India level. CSIR now announced the CSIR Jigyasa Epic Hackathon. It's not about like only interactive session or this boot camp. Finally, whoever are going to participate, they are really going to see their dream come true on that technology development to solve the real world challenges. So it's like it's a kind of a discovery platform and going to create this new India, what we are going to work on promoting entrepreneurship and startups and creating another set of career opportunity for them to school for the school students. So I'm very excited here to state today to introduce the compelling theme of this year Epic Hackathon. The one is clean energy and harvesting and storage, efficient energy utilization management, and waste to energy. The theme our director going to cover this aspect, and the other part is like our one health aspect. Dr. Anshu going to talk about um, very deep level of what kind of technologies currently required and introduce to the broader igniting concepts to you for the school student to come upon some new novel idea. So with that, like I would like to say, this is not only just ideation stage. It's going to have a boot camp followed by very structured program for school student to become real innovator. That's what is empowering people innovation and creativity programs goal is. So you can submit from your idea, design, prototype, technology, smart app. So we have a multidisciplinary labs across in the country. So those once the students got selected, they will go and work with their lab, work with CSIR labs, other incubation centers, so they can really work on the product development. With that, once again, I really welcome you one and all, and thank you so much, Sia. You can over to you.
Thank you so much, sir, for giving us details about the Epic Hackathon and for your encouraging words. Thank you so much. Now, I would like to call upon Dr. K. Ramesha, Director, CSIR Central Electrochemical Research Institute, Secretary, to talk about the first theme of our hackathon, that is clean and green energy. To brief about Sir, he obtained his PhD from IISc Bangalore and was a postdoctoral fellow at the University of Maryland, USA, University of California, and Los Alamos National Laboratory, US. In 2007, he joined as a fellow of Jawaharlal Nehru Center for Advanced Scientific Research, Bangalore. He has published about 100 research papers in international peer-reviewed journals, including 2 papers in prestigious journal Nature Materials. He has 5 technologies and 2 patents to his name. His area of specialization are materials for energy storage, particularly for lithium-ion batteries and other futuristic energy storage devices, and all solid state batteries. He assumed the charge of director of SECRI in 2023. Before that, he was leading the team involved in developing indigenous lithium ion battery prototypes. Over to you, sir.
Yeah, good morning, everybody. Um, this is Ramesh. Can you hear me and can you see my slides?
Yes, sir.
Somebody on? Yes. So everything's fine, right?
It's not right.
Sir,
Yeah.
so
Yes. Tell me.
so it's okay. It's okay. Yes, sir.
Is it full screen or not yet?
Not yet, sir.
Okay. Just a sec. I will just come. It's not full screen. Just can you make full screen? Hide percent of view. Okay. Hide. Is it fine now?
Yes, sir.
Yes.
Perfect.
Yeah. Good morning, everybody. Especially good morning to kids who are online. So I'm going to talk on clean and green energy today. So idea behind this presentation is that to give you some idea of what's going on research on this matter, clean and green energy, and just more than that, idea is to to uh, promote the curiosity in kids like you, so that you will be the next generation scientists and engineers who will take this whole energy theme further ahead. So to make India, kind of self-sustainable on energy matters. So before going to my topic, I'll just um, thought, I will first share you one small slide. This is by Fabio Moili, who is the specialist in artificial intelligence and IoT and cloud innovation. And also he gives, TED Talks. And you can see in Google a lot about him. And he was also head consultant for Microsoft and all that. So he talked, one of his TED Talk was on how important innovation and how important creativity is. So he just showed one, some representation, pictorial representation. I just want to show you this. So you can see that picture. So knowledge is like some dots in our brain. So you can consider some rangoli points, right? So it creates some knowledge in our brain here and there, but it's not a complete picture yet, right? So you have to connect these dots to make a beautiful representation. Okay. And of course, you study in your school subjects, many things, and those knowledge is like very, very isolated in your brain. But through your experience, you will be able to connect these dots. So the most important skill in the future for any country is the ability to connect these dots in your own way. So why I'm giving this example is that uh, in many countries, there will not be enough resources. Maybe many countries are not wealthy enough, but the creativity of people will make these countries to go forward. You know that the countries like, Japan, Korea, and small countries like Taiwan, they may not have much resources, but people created innovations. People created the what we call as creativity, like in a lot of aspects, and that took the countries far ahead. So this is what we expect from our children also. So knowledge is like this. Of course, your experience now from the knowledge and what you other people teach you and all that, you will be able to connect these dots. But still, it's not a beautiful picture yet, right? Beautiful picture comes when you add your creativity. So this creativity gives a beautiful picture. This is called innovation. So the most important skill in the future is this, connecting the dots, what we call as creativity. So creativity is the act of turning new and imaginative ideas into reality. And creativity involves two processes. One is you have to think, then produce something. And most important is creativity requires passion and commitment. So this is the two word, children, most important, that you need to have a passion for something and the commitment. These two will be take you to very successful path. With this small slide, I will go back to my presentation, that is energy conversion and electrochemistry. So, you studied in your school that energy cannot be created nor destroyed, but you can convert from one form of energy into another form of energy. That's exactly what I'm talking today also. We are dealing with these three types of energies: light, electrical, and chemical in our day-to-day life. So this energy can be converted into one form to another. You know that trees, they use light energy, they harvest energy by a process called photosynthesis and convert this light energy into chemical energy, or what we call as glucose and other things. So similarly, we scientists, or for our own applications, convert light energy into electrical energy by what we call as technology called as photovoltaic technology, right? You might have seen all those things somewhere. So we convert light energy into electrical energy using a technology called as photovoltaics. And then from electrical to chemical and chemical to electrical, to convert this energy, we use some called as electrochemical technology, or the devices, electrochemical devices, mainly batteries, fuel cell, and supercapacitors. So these energy devices store energy in the form of chemical energy, And whenever you want, it gives electrical energy. That's how your mobile phone or laptop and or even a vehicle can run, because this chemical, while using these batteries or fuel cell, chemical energy is converted into electrical energy. So let me come to the topic what we call as green energy, right? Green energy is, I mean, it is not the color, it is how you produce this energy. Basically, to produce green energy, we use renewable energy such as solar, wind, water. Okay, so the energy which produced using these resources is transmitted to the place where it's required, and then it's used. It may be to your home or even a charging station for a vehicle. So everything, the energy comes from, since it's renewable energy, we call it as a green energy. Now let's see about what are the renewable energy resources. The first thing comes in mind is solar energy, because we are blessed with so much solar energy. So we can utilize that solar energy and store that energy for our applications. And other renewable energies, wind energy, and also there is hydrothermal, hydropower energy, which we can utilize. And you also know that there is also called as a geothermal energy, where the thermal energy, which is deep inside the our earth, can be utilized for many other applications, like forming the steam and other things. And another thing which is taking more importance nowadays is biomass, that conversion of bio waste into a useful energy. So, these are the few words which you come across: green, clean, renewable, and all that. So what is that, right? So what is the difference between these words? Renewable energy, I already told you, that is the which comes from renewable resources which are constantly replenished, right? Such as solar, wind, and all those things. What is the green energy? Green energy is any form of energy that comes from these natural resources, such as wind, sunlight, and water. So whatever energy comes, because it can be replenished from the renewable sources, so it is green. And while green energy is renewable, not all renewable actually we consider as a green. For example, construction of a large-scale hydropower facility, though it is coming from a renewable source, still there is an environmental impact. So, we may not be comfortable to call it as green. And what is clean energy? Clean energy is the one which doesn't emit any pollution, no carbon dioxide, no greenhouse gases, and no contaminants. So that is the definition of this renewable, green, and clean. So when we talk about these definitions, renewable, clean, and green, it depends on how this energy is created, how they are refreshed or replenished, what is the impact of this energy creation on the environment. So, however, in day-to-day life, we use these words, green, clean, renewable, but there is a slight difference. That's what I just want to tell you. So what is the energy form what we use today? Basically, we use fossil fuels like oil, natural gas, coal, all these things. These are like non-renewable and limited resources, right? Why we use this? Because they are the most cheapest, because we do not spend a lot of money on this. But these fossil fuels are most polluting. You have seen it, like in a vehicle, what we use: petrol, gasoline, diesel. It's all putting a lot of pollution, resulting into global warming, right? So when we use coal and oil, they produce a lot of emissions, CO2 emissions, which are I'm showing you here. Vehicle, factories. So transportation comes to 20-25% of the carbon emission coming from transportation, 30% from industry. Even our building construction, it also counter more than 10 to, because even steel, cement, all these use coal or electricity from coal or another any other gas, other things. So they produce a lot of CO2, and you see that because of that, the whole CO2 amount in our atmosphere keep rising. I was shown the on the right side this plot showing the increase in the carbon CO2 emission year by year, and that's why because of the higher carbon emissions in we what we call it as started global warming, right? The global warming is happening because of these greenhouse gases, the mainly carbon dioxide filling our atmosphere, and it's like an umbrella on the top of Earth atmosphere. What happens is the CO2 is not allowing any no heat radiation coming to Earth, and those radiations, heat radiations are not able to escape through this CO2 umbrella or whatever, like that on the outer space. So slowly the temperature of Earth is going to like an increasing. Even we say that even one increase of Earth temperature more than 1 degree or 1.5 degree is a detrimental, right? It is creating a lot of climate change and other aspects. So this is what the situation we want to avoid now. And this is one I want to also show you something that, since progress of the nation, progress of people, advancement in technology and all that, it also depends on how much energy we utilize, right? So energy, again, when we say utilize, means we are still using the fossil fuels such as coal and oil and other things. So our requirement of energy and use of these non-renewable sources keep on increasing. I'm just showing a plot on the leftmost side showing what is the energy in the utilization in terawatt. Terawatt is 10 power 12, right? So you can see that as number of years, like from 2000, 2010, 15, 20, 30, 35, our energy utilization keep on increasing. At the same time, our fossil fuels, whatever we are having, like coal, oil, all this kind of their their amount keep on decreasing because we keep using them. They are non-renewables. So what will happen in situation that in 2035 we will have a challenge, what we call as a terawatt challenge, that whatever energy what we have will not be sufficient to provide enough energy to all our technologies and other things. So this is the biggest challenge what the world going to face if we are still going to use non-renewable resources. So this is something I just want to show you how much time you left. For example, our oil deposits shows that the way we are using today, it may come up to next 40 years. Natural gas up to next 6 years, and coal more, close around 200 to 250 years. So that's what means we have only the limited resources. If we finish it now, the next generation will have more difficulties. So that's why I'm just showing you this picture. You can see on the leftmost side, we are showing a pictorial representation of the resources. On the leftmost side, what we see is that non-renewables like coal, natural gas, those three spheres. And right side, you have renewable resources. I'm just representing by those spheres. The sphere size shows the quantity, how much we have, right? The big sphere, the yellow one, is the sun. So you can see that the leftmost thing, this is a coal energy, this is a small sphere ball. Right side, we have a big sun, right? So that shows that in front of solar energy or the energy of sun who's radiating us, all other resources looks very, very dwarf. That means sun, he gives energy to earth. For example, in 1 hour, the energy what sun gives to us is enough for us if you can store for one year full. So if you can store energy of the sun in 1 hour, that's sufficient for the whole earth whole world to be to use for 1 year. Excuse me. So that's why storing solar energy is an important factor, because it will solve our challenge, what I told, 1 terawatt. Because sun radiation itself, it is like 1,000 times more than what we need to overcome that tetrawatt challenge. Sorry, terawatt challenge. So what we should do? So we have to move from non-renewable resources to renewable resources, like from using fossil energy, petrol, gasoline, start use solar, wind, and sea, ocean energy, ocean water energy. And you have to store this energy, right? That's another important thing. And from petrol, gasoline engines, move to electric vehicles. So not only you will be reducing the CO2, you also can use renewable sources to run your vehicles. And for all these, what you need is good batteries to store this energy. So the world will change when you have good batteries. So when I say good batteries, means which are very efficient, which can store energy, and it can very sustainable, safe, and all those things. Let me show you one picture. So this is what I call as revisiting the past. This is 100 years of story I'm showing. On the topmost, the picture is in black color, so you can figure out that these pictures are much older, taken 100 years ago. So electric vehicles, what we talk today, it is not just today started. It started 100 years ago, beginning of 19th century. On the top, you have an electric vehicle. You can see that one man is riding this four-wheeler, but all that vehicle is filled with the batteries, because that time the battery technology was not so advanced. So they used the very what premier technology that time of batteries, and that's why only one man can sit, and this vehicle can go at the hardly at maybe less than a kilometer. And at the same time, the revolution of telecommunication also started. On the right side, there is you can see the person standing, and on his shoulder there is he is holding a battery, a very heavy battery, right? So it took 100 years from that situation to come to the bottom situation, where you can see an electric car, four-seater, with the four people sitting, driving a car for around 300 to 400 kilometers. Similarly, the telecommunication, the mobile phone, what you have today, handheld gadget, it took 100 years from top to come to the stage where you all can have a mobile phone. It took 100 years. Why? Because we did not have a good battery technology. We did not know how to store energy in batteries. It's because the technology was not optimum. And even today, it is not optimal enough, because we can use batteries for our mobile phone. But when we talk about EV running vehicle, still our batteries are not good enough. Just a minute. So when we talk about these energy devices, we talk about electrochemistry, because electrochemistry always gives the green energy. So you have studied in your class electrochemistry a bit, because what we call it as, it deals with the gain or loss of electrons. And the whole in electrochemistry, it's the electron which is a chemical reagent. It goes from one anode side to cathode, or cathode to anode kind of thing. And mostly these electrochemical processes are very reversible. And they will bring this chemical change without any producing any toxic reagents or hazardous conditions. So that's why we consider electrochemistry always gives a green products. So that's why all these devices, battery, fuel cell, which uses electrochemistry, are considered as clean and green energy resources. Okay, so everything going fine? Hello?
Yes,
Can
sir.
somebody respond? Yeah, okay, great. Yeah. So when we talk about these renewable resources, energy, solar, wind, hydro, all this, they are intermittent in nature. Means they are not continuous, right? Energy, solar, for them, sun in on daytime, night there is no sun. Wind sometimes blows, sometimes not. So whenever there is energy coming, you need to store that energy. Solar, wind, hydrothermal, all these things. Okay. So to store that energy, you need the devices. For that purpose, now we realize that electrochemical devices are the best one, because I already showed you that electrochemical devices store this energy, electrical energy in form of chemical energy, and when you need, they will give back as an electrical energy, and that they don't produce any pollutants or gases, so they are always give a clean energy. When we talk about energy technologies, electrochemical energy technologies, there are mainly there are three type of energy devices, electrochemical devices. What we call them as fuel cells, batteries, and supercapacitors. On the top, I am showing you the how in a mechanistic view what a fuel cell, battery, and supercapacitor like. And on the bottom picture, I'm showing you a real device. Okay, so since they're all electrochemical devices, they have one anode and one cathode. This is for common to all electrochemical devices, whether battery or supercapacitor and fuel cell. Okay, and these electrodes are separated because if you cannot put them together, there should be something which non-conducting. Non-conducting agent should be there. So it separates anode and cathode. But this non-conducting matter, what we call in between electrically, should conduct ions. Okay, so it should conduct only ions, not electrons. Electrons should be needed for utilization in our activities, like for running or using your mobile phone and other things. So all these three devices, they have anode, cathode, and we call as a separator or electrolyte. Okay, so from one the ions will move to the other one when you charge or when you discharge, while the current electrons will move through the external circuit, giving you the current. The actual how they look like that I'm showing you at the bottom, as you know, fuel cell, batteries, and supercapacitor. Battery and supercapacitor, you can consider them as the work principle, everything more or less same, whereas fuel cell slightly different. What the difference between these three? I'm just want to show you, since you are kids, you might have not studied everything. Just want to some representation here, how for the understanding sake. What we call as capacitors have very high power, but they give power at very short time, maybe 1 second, 2 seconds. Whereas batteries and fuel cell, they do not have much power, but they have good energy density. So they can run, even a battery can run for, full 1 day. Whereas the capacitor can give in 1 second full power and dead kind of thing. So just to tell you what the difference between a capacitor and battery, you can think of runners, like a sprint runner who runs for 100 meters or 200 meters. Like he needs power for 100 meters running, like very fast. He has to run and so fast. That's like a capacitor. But a marathon runner who has run 42 kilometers around needs not much power, but long energy, right? That's like a battery. So batteries and the fuel cell give long hours of energy, whereas the supercapacitors give burst of energy or power for a very short duration. So for application now we talk, sometimes like for you want electric vehicle, you want to run for 400 kilometers, you need battery for running 400 kilometers. But many times these cars also need to go uphill. So you need power, right? So what we need is both combination of battery and capacitors, what we call as hybrid battery and supercapacitors. When I talk about battery, whole research started maybe, you can say that 200 years ago by Galvani, who showed that when he called this as an animal electricity, when he touched, you can see that picture on the rightmost bottom, that two dissimilar metals, when he connect to a frog leg moved. So he thought that it's actually the frog leg has some electricity, so it's moved. Actually, though his experiment was right, his conclusion was wrong. That was corrected by Alexander Voltron, the next scientist, who showed that it is actually not the electricity in the blood, but two dissimilar metals, when you connect, it conducts electricity. So he showed what we call as voltaic pile, where two dissimilar metals, when they kept top of each other, and then they separated by an electrolyte, like you can consider tissue paper wetted in water, then it creates an electricity or voltage across. Further, there is a development, Daniel Cell, who showed that when two solution, copper sulfate, zinc sulfate solution connected by external wire, there's electricity flow and all that. And you also studied about Michael Faraday, the genius Michael Faraday, who did a lot of experiments, and that gave us the modern days battery. Okay. Earlier we had what we call as dry cell batteries, or called as primary batteries. Then recently we also have something called as rechargeable batteries, right? Rechargeable batteries are rechargeable many times. For example, nickel cadmium, nickel metal hydride, lead acid batteries, and now we have lithium ion batteries. You all have in your mobile phone, that's what we call as a lithium ion battery. Still, I told that though it's enough for our mobile phone, but we are looking for more and more improvement in this technology. So we call it as next generation batteries, like sodium ion, lithium sulfur, lithium air, all coming up. So how battery works? A principle called standard reduction potential. You may be studying in your class now or maybe later. So just remember that when two metals of dissimilar metals have difference in their standard reduction potential, they give the voltage. That's what the principle used in batteries. I'm not going to talk to you on more on this, but when you study, you remember this principle and then connect it to our principle of batteries, how the battery works. And this is some experiment which you can do in your school or home. You can, what we call as a fruit battery. You can take an orange and pierce two different metals, maybe a nail and a copper wire, and you can measure a voltage across, right? Or you can even collect a LED bulb and see that's a voltage created. Basically, there are two metals, copper and zinc, and the fruit act as an electrolyte. Electrolyte is having ions. You remember, no? Fruits have acidity inside, acidic water, so that conducts electrons, so it completes the circuit. Similarly, you can also do coin cell battery. You can have two different coins, like made up of copper and zinc, separated by wet tissue, and you can put them in top of each other, and then you can create a coin cell battery, and you can measure the voltage, and also you can glow a LED bulb. These experiments you can do in your school or at home. So I talked about two types of batteries: primary, that means you use and throw, that are the you use in your torch light, or even remote TV remote and all that, where the battery, the usage is very small. The battery whatever you use, it will come for 4 to 5 months. So we use those for there are disposable batteries, but secondary batteries are chargeable repeatedly. You can use them, charge and discharge. Um, what you use in your mobile phone, like lithium-ion batteries. Okay. So these batteries, how you can connect them in series and parallel. I'm just showing you. When you connect batteries in series, as in your torchlight, you can see that there are 3 batteries connected, right? Positive, negative kind of thing. That means, and when you connect them in series, the voltage will increase. It's the addition of voltages. But when when they are connected in parallel, voltage remains same, but current will be added. So this is the principle what we use when we make when we make a battery pack. Okay, so for example, if you see an UPS battery in your school or somewhere, you can say that they are connected in a series and parallel to produce the required current and voltage. So though there are lead acid batteries, which is in your UPS, then there are batteries called nickel cadmium, nickel metal hydride. Few years ago, we used to use them, but now we more or less we are using lithium ion batteries, because that's why I'm showing the plot here. They are the lighter weight and the small size. That means lithium ion batteries can store more energy with the less weight. So for example, in your mobile phone, you have lithium-ion battery. And because that's why your mobile phones are lightweight. Think of if you have to use a lead acid battery, you cannot even lift your mobile phone, right? So that is where the advantage of lithium-ion. They are very lightweight. They can store energy, large quantity of energy in a small device, and that's why we can think of lithium-ion batteries uh, for other applications like electric vehicles. So they come in 2-3 different formats, means how they look like: cylindrical, prismatic, pouch, and coin cells. Okay, depending on your applications, you can use different format. Industries use different formats. For example, in your mobile phone, you use prismatic batteries. So lithium-ion batteries, now because of they've become so popular, they're almost everywhere. So for example, your mobile phones, PDAs, and drilling machines, all these use lithium-ion batteries. So now we are also thinking that to go for EV, because we want to stop usage of oil, petrol, gasoline, and other things, because the CO2 emission. The best suitable choice is lithium-ion batteries to run a vehicle. So that's why they have become more and more popular. These batteries for storing and running electric vehicle, and they are rechargeable also, right? So in CSIR, we developed battery technology. That's what I just want to show you a slide here. You can see the leftmost, that cylindrical batteries produced in the same building where I'm giving a talk today, and they are shown for various applications, for lighting applications, solar street applications, and running bicycle, scooter, and all these things. So we are building this technology, and also we want to improve this technology further. So let me stop batteries. Let me quickly go to fuel cell, right? There's another energy device. How it works? For a fuel cell, you need 2 gases. Hydrogen on the left side, you can see that hydrogen coming on the gas from left side, oxygen from the right side, O, and these gases come to in between the layer. There are what called as catalyst layer. So hydrogen is split into H plus, that is a proton and electron. So the membrane between what we call as proton exchange membrane allows only this H plus to pass through, but not electrons. The electrons goes through the external circuit where I shown there's a bulb. So the H plus goes through the membrane and to the other side where oxygen is coming, and it reacts with that oxygen producing water. So H, hydrogen, H2 and oxygen, they combine together producing water and energy or electricity, E, right? So there is no other product, only water and electricity. So it is a clean source of energy. So this also an important technology is developed now. And left side, I'm showing what all the components, just for you have a visualization. In our laboratory, we make these fuel cells. You have various components. You can see that terminal plates, graphite blocks, there's anode, there's a cathode, gas diffusion layer, then there is a catalyst layer which split hydrogen gas into protons and electrons. Similarly, oxygen gas into O2 minus. So I'd pass through that producing water and electricity. The actual how it looks like, the fuel cell I'm just showing on the right side, it has many such components stacked together, tightly packed together. And as I said, it's a connected display on the series so that I'm showing you the voltage around 14, right? This is how the actual fuel cell look like. You can see that there are red and blue pipes. That's where the oxygen and the hydrogen passes through that to the fuel cell. When we talk about fuel cell, we talk about hydrogen, right? Hydrogen is one important reagent. So nowadays, hydrogen is gaining more and more importance because not only for fuel cell applications, hydrogen is can be also directly used in place of gasoline or oil or petrol for the electric vehicles. Also, hydrogen is used for many chemical reactions, including ammonia synthesis and other things, right? And other other methanol, ethanol, so many things. So hydrogen is becoming an important reagent. So as an energy carrier. Hydrogen can be produced very simple way by electrochemistry. You all know that splitting of water into hydrogen and oxygen, right? Using the solar energy, you can split water into hydrogen and oxygen. So hydrogen can be hydrogen can be obtained by splitting of water by passing electricity, and electricity is can be generated from solar or even wind. So that's why we call that hydrogen as a green energy resource. That the splitting of water into hydrogen and oxygen, right? That process is called electrolysis. You might have heard this in your school days. You might have studied all this. I'm I'm not showing many of what is the exact how working principle and all that, but what we call this as electrolyzers, electrochemical electrolyzer, where the electricity or solar energy can be used to split water into hydrogen and oxygen. A lot of research is happening on this also, because it is not as simple what I say, because you need what we call as a catalyst and other things. So to overcome the potential barrier. So a lot of research on this activity, how to make an efficient electrolyzer, how to make more hydrogen production. All this is a research topic. So this is what's happened in my institute. We do a lot of R&D and producing water electrolyzers. You can see those 2 cylinders in the topmost picture where we can store hydrogen and oxygen. And the right side also there is a building I'm showing, where on the top of the building there are solar cells. So we just harvest that solar energy. That solar energy used as gives an electricity which is used to split water and hydrogen. Again, I'm just showing you that how the green energy or green hydrogen can be produced, right? The bottom, I'm just showing you the picture of the heart of electrolyzer. That is called electrolyzer stack. Since I'm not having much time, I'm just quickly going through the slides. So green hydrogen is a circular economy because electrolyzer and the fuel cell work in a reverse way, right? The electrolysis, you split water into hydrogen and oxygen, whereas the fuel cell take this hydrogen oxygen and combine and make them water and producing the electricity. So use solar energy for the electrolysis, split water into hydrogen and oxygen, and now store this hydrogen, and you can use as transport. You can transport this hydrogen wherever you want. Okay, and for the filling stations, hydrogen as a gas, or hydrogen can be sent to fuel cell engine, and oxygen also can be passed to the engine, and it produces energy and water, and the energy can be used to drive the engine like a vehicle, and whatever water produced can be reused for the electrolyzer, right? So that means if you have 1 cup of water, and if everything goes very well, you can, using an electrolyzer and a fuel cell, you can continuously generate energy and water. Such a fantastic dream, right? No emission, other emission, nothing. You can continuously run your vehicle with 1 cup of water. So, however, there are many, many challenges which we are working on today. And I hope that this technology give you enough ideas to take up this energy as your research and come up in the future with the new technologies better than what we have today. So considering the importance of hydrogen, Honorable Prime Minister, during the 75th Independence Day, that's the 15th August 2021, has declared, like, National Green Hydrogen Mission. He launched a National Green Hydrogen Mission that all R&D labs and the nationwide industries to work on hydrogen generation and storage. So CSIR laboratory, along with few other industries like KPIT in KPIT technology in Pune, we developed fuel cell, and we put in the fuel cell in a bus, indigenously developed the bus and the fuel cell technology, and we made this bus to run on hydrogen fuel cell. So this is only a demo, but this will open up many such future tasks in India. So with that, I'm closing this hydrogen fuel cell battery supercapacitor. One more interesting topic is biomass. Just I have a couple of slides because since I'm running out of time, I'm just show you how important biomass is for energy. Biomass means it is a, it's whatever leftover from agricultural crop residue, industrial residue, and even it can be a municipal solid waste. All this considered as a biomass. We can use this biomass, and then we can produce many useful chemicals. First of all, like we can produce hydrogen, we can produce methane gas, we can produce many bio oils, right? And many other useful chemicals using this biomass. And so, and also biomass in the villages used to produce biogas. You might have heard about this. And this biogas using like from the cow dung, other things, and they can produce biogas. And this biogas is nothing but methane, which is used for cooking purpose. So biomass, whatever we thought is a waste, now no longer is a waste, it is a wealth to the country. So we can, if we properly utilize this biomass, we can produce gas like hydrogen, methane. So it can increase farmer income, and also it can give a solution to climate problems. So we'll no longer burn them, but we'll convert this biomass into useful chemicals and hydrogen. So I'll just conclude with this slide with a message to all kids here that innovations are very much required for us. Whatever I talk today, whether it's a battery, fuel cell, or even technology from biomass, these are in the, like, very preliminary stage now today. Though we can show some applications, still they are not fulfilling the major requirement. Like, for example, we want to run electric vehicles using battery or fuel cell. There are many challenges. Like some challenges like efficiency of these batteries, fuel cells, safety of batteries, sustainability. There's another question. And all these cost related things, right? So batteries and fuel cell, they are so costly that we are not able to use it. That's why we're still using coal and other things for energy generation, because the cost problem is still there, and the material. When I talk about batteries, fuel cell, there are a lot of materials involved inside. Either they're very expensive material like platinum, iridium, all those things, or they are not available in our country. So that's why we have to import these materials also. And of course, the fourth challenge is how to reduce weight and volume of these devices, energy devices. So these are the challenges, and still we are working on that. And the kids, so I ask you to take up science as your future, what that called as inspiration. And you will be able to answer these questions, whatever I put here. And you can bring some breakthroughs so that one day we can use these energy resources like solar and wind more efficiently and in a cost-effective way. And another most important part is out of the box thinking. Like what I showed one of the slide where, even though battery technology was known 100 years ago, EV was never popular because the batteries were not good enough to run those electric vehicles. And people never thought telecommunication will be one day it will be like, such an easy task, because they did not have batteries. But now all of you carry mobile phone back, because there was a breakthrough 20 years ago that lithium-ion batteries, that technology has been developed. So such out of the box thinking is very much required in all these energy devices and tapping solar, sun and wind energy. So to accelerate these things, what we say clean and green energy transition, that requires accelerated innovations, and keep your ideas open and keep your creativity open all the time. Thanks a lot.
Thank you, sir, for giving us deeper insights into the theme. If there are any queries from students' side, we will get in touch with you, sir. Thank you so much, sir.
Okay, thank you.
Now I would like to call upon Dr. D. Shelja, Chief Scientist and Chair, Business Development, CSIR Indian Institute of Chemical Technology, IICT, Hyderabad, to talk about our second theme, talk about SNT innovation and entrepreneurship. To brief about ma'am, she obtained her PhD degree from Osmania University and IICT. She was also awarded CSIR DART Fellowship in the year 1996. Her research interests lie in the areas of coarse shell polymer emulsions, polymer inorganic nanocomposites, fluoroacrylates for functional coating, and polymers for controlled release applications. She has worked on several projects of national relevance, sponsored by both government and private industries, and has around 30 publications to her credit. She was also listed in the 5,000 personalities in the world by American Biographical Institute in the year 1998. Over to you, ma'am.
Yeah. Very good morning to all of you. I thank the CSIR JIGYASA HRDG team for giving me this opportunity. Very good morning to all the sister labs colleagues who have joined this call, and most importantly, the students who have joined on YouTube from across India. Thank you. And I would like to now make a presentation to you on, okay, my screen is visible, right? Someone can kindly confirm?
Yes, ma'am. Yes, ma'am. It's visible.
Yeah. So, right. Then the topic that I would like to talk to you all today is on science and technology innovation and entrepreneurship. This is basically to ignite curiosity and creativity in students. Particularly, the outline of my talk would be kind of giving you an overview on entrepreneurs, entrepreneurship, the science technology innovation interface, and what is the power of innovation and IP? How do we foster this innovative mindset and build those internal capabilities and competencies, have certain best practices adopted so that we really coin a very good problem statement and give it a value proposition through our solution. And then how CSIR is going to help you with maturing of that technology through their mentorship. And then eventually the kind of impact that we are going to make on two sectors, because these are the two topics that we have chosen for this EPIC Hackathon 2024, that is in healthcare and energy sectors. So to start with, let me make you all understand on entrepreneurs and entrepreneurship. You know, it is told by Peter Drucker that the best way to predict the future is to actually create it. These entrepreneurs, through their entrepreneurial avenues, are going to do that. So you know what the future requirement is and try to provide your solutions in such a manner that that future is going to be yours, you know, the way you dream it. So entrepreneurship actually is nothing but it empowers individuals to shape their destinies and contribute to the growth of the society. So whatever we are at this time, you know, from here on to where we grow and make that future ours, owning it up as our future is what the entrepreneurship is all about. So successful entrepreneurs are none but, you know, they convert their innovative ideas into businesses. They also know how to realize their dreams and contribute to socio-economic impact. And the characteristics that are very essential for an entrepreneur is to be very creative, resilient at the same time, not just creative, which is a novel idea that you would come up with, but resilience is important because you need to come back and be very have this ability and agility to face any unprecedented setbacks, and then have a proper vision to realize your mission and your entrepreneurial avenue idea that you are thinking about. It is actually the need of the hour, I would say, mainly because these new technologies and service models that we are creating, having this kind of a risk taking and wanting to convert these innovations into an enterprise is the one which drives the economic growth. So both economic growth is going to raise the GDP of our nation, and the GDP of our nation, if it is raised, only then we are going to become the developed nation. You know that being a developed nation to be called as, you need to have a certain level of GDP in the country. And for that to happen, you know, we are laying down this path by having more and more number of entrepreneurs trying to get into businesses through their innovative ideas and contribute to this economic growth of this nation. And that's the roadmap that CSIR is also making through this Viksit Bharat. For 2042, we have a goal for us at 100 years of CSIR, and then on to the nation's dream of 2047 to be that 5 trillion economy that our Honorable Prime Minister, who is also the president of CSIR, is dreaming about. So to give you a few of the examples of the successful entrepreneurs. Own your rooms, own your own rooms is something which was started by Ritesh Agarwal, and he actually, created an international startup, I would say. This was a breakthrough innovation, which he came up at a very young age when he thought about, if you read about his story, you will understand he has become a prominent figure. This is basically for standardized accommodations where you can have in different cities, and also now it is on international platform. Paytm again, Vijay Shekhar Sharma, he has come up with this particular digital payments, e-commerce and fin tech services platform through which, on a global stage, he got a recognition. Ola, again, all of us are aware of having a sharing riding platform in cabs, where, even in two-wheelers, and Bhavish Agarwal came up with this particular innovation through which he could really make a difference to the taxiing that we have had earlier. Zomato again by Deepinder Goyal. He has come up with this particular online food delivery and restaurant discovery platform where, globally, this was very good tech and contributed in a big way to the startup ecosystem. And then you have the Snapdeal, Kunal Bal. Snapdeal is again, I don't know if you, the students are aware of, if you have a different online e-commerce platforms, there is a comparative analysis done, and then you can choose the best deal out of, if suppose you're purchasing a mobile or so. And that's something which Kunal Bal has come up with. So these are some of these, and one Zerodha is also noteworthy to mention, where most of the people in fintech, they are trying to trade their shares, and this particular brokerage firms, he has impacted in a big way, coming up with a user-friendly online platform. So students, it is not difficult. These people are all recent ones which I have showcased to you, who have survived even the COVID bad times. So what is it all about? How are we going to use science and technology innovations, convert into businesses? You all understand it was the science year of science, those 2 years during the COVID 19, that we have had a very traumatic and very difficult phase of confining ourselves to our own homes because of this dreadful disease, COVID-19, which was a virus. So science, I would say, had come to their rescue. You know that you can just read from the slide that it is an engine that drives discovery, and technology is actually a vehicle that makes these discoveries translate and be used as an application for our day-to-day use, which is actually, when those two things come together, it shapes the future. But innovation is actually is a process that converts this science into wealth. So if I'm giving academia industry, you can actually look at it as science, the knowledge, and then the wealth, what we create is the technology translation, I would say. These TRLs probably you kids are not really exposed to, but a TRL full form is technology readiness level. So you have from 1 to 9, from where, from basic research or a technology or an idea that we convert into a proof of concept is by TRL 3. And from here on, the technology demonstration and prototyping and piloting happens, that kind of a scale up until TRL 7. And from there on, we have this up to TRL 9, we call it as commercialization and launching of a product or a process or a service. So from knowledge development, which is science, to technology development, to business, is what actually an innovation can, in science and technology or in any other field, can do. But in science and technology, I would like to draw your attention to, mainly because giving you a small example of COVID-19, there was a startup, BioNTech. This was a German startup building an ecosystem that values the innovation and rapid development. We have also done a lot of technologies in life-saving drugs through repurposing of drugs, and also in vaccines. But this company really made it very big by giving this technology to Pfizer, and that is how we could have the vaccines of both Covishield and Covaxin over here, was also assisted by our own lab, IICT, with an adjuvant technology given to Bharat Biotech. So this is how innovations in science and technology can create an impact on the lives of people with respect to health or any other innovation for that matter. I'm giving you an example of health here, wherein we were all put to a very difficult phase of COVID-19. So what is it that innovation, on the power of this innovation and intellectual property? Why should we patent? What is intellectual property? The importance of intellectual property comes into picture when you're trying to think about an idea. This idea has to be so innovative. Only then that front end research on the gap, if you do on the S&T trends and look at the unmet medical needs or unmet needs of it is, if it is healthcare, it is unmet medical, but if it is energy sector, it is unmet need of in any other stakeholders, or the current scenario of industry and the solutions that we have around. It could be even small things. I would take an example of a vending machine. Earlier, we wouldn't have these vending machines. We would always had to go to a store, but now you can put a coin and have a water bottle or a juice or a chips packet in many places. So like that, these are all small innovations where there was a gap, and that gap was fixed with a solution. That solution with an existing solution value gap, when you see, that is how you create a differentiated product. So what I would like to showcase in this funnel to you is a strategic stage where you're trying to ideate and try to find a gap and come up with a solution. You should actually fit it into this during this stage. It is very essential. If you don't, then you cannot really go into an operational stage, and the innovation process cannot reach its commercialization. If it is not commercialized, then the idea or the knowledge is as good as staying in a shelf and not being useful for the society. So students, it is very important of how your innovation has to be before you conceive that thought and idea, for it to be fully a product or a service or a process, to be a new process development or a new product development, so that it goes into commercialization. So creating value, be it process, product or service, that is what is actually, that new technology is what is a defining characteristic of innovation. So this is innovation. If you have that innovation, then the technology readiness levels that I explained in the previous slide, you can reach up to 9. The value, if you patent it, only then you are going to get the highest value accrued. Otherwise, you're going to stop here at the proof of concept, and here is where you will transfer your knowledge. But if you hold on to filing an IP, if you protect your intellect of your innovation or your findings, then the award or the reward it accrues is huge. It is several bounds. This high it will be. For example, I would like to give you a CSIR or a similar organization in Australia. They had filed an US patent sometime in 1996 on Wi-Fi networking. You all are using now the Wi-Fi technology, and I believe more than 3 billion electronic devices worldwide are, all having this Wi-Fi. And why am I telling you this? Because when people started using Wi-Fi, not giving them the royalty or the acknowledgement because of their patenting, then they sued. There was a massive litigation. They sued, and now every company, the mobile companies, the personal computers, and all these video gaming enterprises, they all had to shell down an amount of $220 million for CSIRO in 2009 because they fought this case and won. So this is being accrued as royalties for all the years, and that could exceed more than $1 billion US. Can you believe, students? This is the power of innovation. So if you file your patent, if not now, in future, if someone adopts this, you have so much of advantage of getting that innovation to be put to use by so many people worldwide. So that is the power. So drawing your attention to the WIPO's Global Innovation Index 2022-23 is yet to come. So the India's position, we are at 40th rank out of the 132. If you see the Global Innovation Index map, the Switzerland, US, all these people, the top 10 positions are by these nations. And where are we? We are 40th. So I am looking up to the young leaders, the students now, to take up S&T innovation, because future of innovation driven growth, that is the future. That's it. So this ranking can be changed by these students who can make India as developed nation. The scores, what they take up is business sophistication, human capital and research, the institutions and the infrastructure, the creative outputs, knowledge, technology outputs. These are the indicators to give you the score. And the WIPO Director General, he said that underperformance in innovation-driven productivity is the main concern, because innovation, if it is there, then productivity will increase. So we need to pay more attention to not just investing in innovation also, but how it translates into economic and social impact. So it is very, very essential that these innovations translate into businesses and they actually make an impact on the society and the economies. So that is decided by the quality and value of this particular innovation. So I would like to quote Honorable Prime Minister's saying during 108th International Indian Science Congress that India's scientific community will ensure a deserving place for our country, and that is possible only with IP and filing of patents that have commercial potential. I want to emphasize on the commercial potential here. So we are really looking up to these students who are going to be the future leaders, future scientists, and future technologies, and future entrepreneurs who will come up with these innovative ideas that translate and come up into commercial being in the form of a businesses. Here, I would like to say, now, how do we actually foster this innovation mindset? That's very important for you all. How do you all actually ideate and convert that into an entrepreneurial avenue? So it's highly important that you have a human-centric education. You should think critically and adapt yourself to this analytical thinking abilities. You should always have the empathy and the environmental responsibility besides the ethics for you to coin and ideate your thoughts to come up with a solution to this problem statement. And then continuous learning is very important in this tech-driven world. If you are not dynamic and constantly changing and innovating, constant innovation to meet those changing demands, then also you cannot really be successful as an entrepreneur. And you should be embracing complexity, I would say, because this complex is from the complex systems actually to convert from technology that is applicable to society. You need to have multifaceted challenges you will have through interdisciplinary learning. Suppose, now in health, it is chemistry, biology interface. You can't really have one discipline with which you can have a complete and a comprehensive solution. Similarly, for having those holistic solutions, you should have multiple factors being taken together to lead to a solution that is going to be beneficial to the society, which is affordable, accessible, and achievable for entrepreneurs. The resilience and adaptability is another important factor to have as an innovation mindset, is because in this uncertainty of age where you never know what kind of unprecedented changes are coming, the challenges and opportunities should be embraced. challenges should be embraced as opportunities and try to come up with ideas that can actually combat those situations. And you should be really very agile and adapt to change. And here I would say collaboration is the way forward. If you do not collaborate with other stakeholders who can contribute towards your solution, then you can never do in silos any solution in a perfect manner. So it's very important how you collaborate with your stakeholders of different stakeholders who come in and contribute to your idea to be converted into practicality. And then creativity and innovation, which my predecessor, the director of SECRI also told you how creativity actually drives to problem solving, giving you a very nice idea of how to connect the dots. That is going to really shape up an idea into a product or a process or a service. So, and your risk is always there when you're trying to come up with something very new and innovative. You have the risk, but should not fear the risk. Reliance's Ambani has actually told that the youngsters should not fear that risk. You might fail. Most of the startups fail, but then we learn from those failures and then move on. There is a saying that an enterprise might fail, but an entrepreneur will never fail. That is because he will have that passion to constantly think, evolve, and be a better version of himself with respect to his ideas for making an entrepreneurial avenue that resolves or gives a solution to some existing problem. So imagination and intuition, that is what is thinking out of the box. The energy challenges that were given by the director of SECRI, you should now put your imagination and intuition. So that is thinking out of the box. Sustainability and responsibility, these are very, very important things, because if you are not thinking and if your idea is not a sustainable one, then we are not really friendly to our planet. So ethical businesses is the norm. So you should be thinking about what are your effluents. If it is a chemical business, if you are into any kind of business that is going to give some repercussions to the planet or the well-being of people or the planet, then it is not acceptable as a business. So well-being is our responsibility of the planet and the people. Eventually, I would like to say that innovation and entrepreneurship are not just buzzwords. Everybody is using them, but they are actually the skills. Entrepreneurial skills and innovative skills are actually very, very important for you to inculcate so that you can solve the complex and critical problems that we actually are facing today in this world. So here I have a small exercise for you all to ask yourselves on how you can build those internal capabilities. These are some of the questions you should ask yourself to build practices. Do you seek truth or confirmation? Do you challenge your assumptions or look for evidence that supports them? Yes or no? Do you risk something different or go with the crowd? Do you try something new or follow the norms and expectations of others? Yes or no? You people can actually type your answers. Do you focus on the best solution or individual win? Do you collaborate with others for the common good or compete with them for recognition and rewards? Do you look for truth or praise? Do you welcome constructive criticism or crave positive feedback? Do you do anything new or what you know? Do you experiment with different approaches or stick to your comfort zone and repeat what has worked before? Do you try to be good or make up lies of how good you are? Do you admit your weaknesses and work on your strengths or pretend to be more competent and confident than you are? Do you say what you think or what people generally say or agree with? Do you express your own views and values or conform to the opinions and beliefs of others? Do you see failure and human vulnerability as opportunities for growth and empathy, or as signs of weakness and shame? If you all have had questions has had questions that, oh, sorry, I'll just escape from the presentation mode so that I would like to temporarily, so that I could show this for all those who have had the answer yes to all of them or any of the later options. in each set of those questions, then your culture is not conducive to innovation and entrepreneurship. This is what I wanted. I don't know how many of you all have said yes. If yes, then you cannot be an entrepreneur. That is what I wanted to say. So you need to be more curious, open-minded, collaborative, feedback-oriented, experimental, authentic, independent, and resilient to be an entrepreneur. These are your internal capabilities and competencies that you need to have to be the person whom you want to be if you want to embrace entrepreneurial avenue as your future career option, particularly in science and technology, but even otherwise. So how do you choose your problem statement? And how do you arrive at your solution, which is having a value proposition? That is how you should think now. Now that you understood what you are, how you build your capabilities, what innovation is, what IP is, and what science and technology can actually make an impactful change to your lives, it has to be always customer centric. You have to keep your customer in your mind when you find a gap and you want to come up with a new idea or a technology or a service. Then you have to always have this customer and in your mind who is actually going to be the person who is going to use it. And then you have to think about constant improvement in it. So value proposition, that should be the focus for you to come up with a problem statement. And then you have a value proposition of setting your goals of the outcome very clear, and clarity you should have. So and how to have this vision and mission enabled through innovative strategies that you need to also write a roadmap for yourself to achieve that that problem, the solution to that problem statement. That will be your value proposition. And then you should always have these strategic partnerships and alliances without which you cannot. So creativity, Albert Einstein told this, and I quote, intelligence is actually having fun. It'll be a lot of fun. You can come up with this strategic perspective and ideas in your day-to-day life. You can see so many gaps. Those things you can fill with certain science and technology in the topics that we are proposing today in One Health and also in energy sector, the cleaner and greener alternative energies. So if you come up with those and have this idea of global creativity and innovation that can meet those local markets, and then you can seize these opportunities and leverage and become a winner. So here is something which I would like you to also understand, that when you come up with this idea or an innovation, our CSIR labs, as my colleague Dr. Partha told in the beginning, we would be mentoring you for the maturation of the technology, particularly once the technical gap is identified, how good it is and how we to refine as per the market value and the state of the art trends. And then we would help them in assisting for the patent drafting. If it is really having that potential, then, the patent drafting can be held by CSIR laboratory of the concerned solution that you're coming up with. And then we can help you in assisting, claiming the drafts and specifications, and then look at the analysis of patent landscaping and patentability search. So this is how we are going to mentor the student during as per the EPIC Hackathon, during your summer. The selected candidates will be put to training in the relevant laboratory of CSIR, and then you will refine your technology so as to go ahead with patenting. And then the TRL level 4 would come, where you have the proof of concept. Then probably your respective schools can decide on how to go about of converting that into business by getting into partnerships with any industry. So students, I would like to also tell you all over here that some of the stories of our own laboratory, how we could make a difference with a discovery and the patenting, how it realizes and makes an impact in both this healthcare and energy sector, because there are many. I thought I'll just showcase this as an interesting thing for you to get inspired to come up with these innovations and be entrepreneurs of this nation. So this is a new chemical entity which we gave to Sun Pharma. We had 3 patents which we had out licensed to them as tech transfer, and we got 240 crore. This 2.4 was for billion, sorry. So that, which includes both milestone payments and royalties. So that is the kind of remunerative and monetary benefits one gets besides the societal benefit, where the unmet medical need would be a solution would be given to the people, and the common man can benefit out of this particular innovation. So the scientist who has contributed to these patents would always have that complete satisfaction of his patents being converted into a product. Similarly, to Bharat Biotech, we had given this adjuvant molecule during Covaxin. You know that our Honorable Prime Minister also had this vaccine shot, and they had supply chain issues during COVID time, and we came up with this, and so many lakh units, 3,516 lakh units were given out, and export units were 504 lakh units. Around 50 countries were beneficiaries of this vaccine. But for our adjuvant, this vaccine would not have been complete with its recipe. The adjuvant molecule is the one which amplifies the active agent as a vaccine component. And this, I call it wealth out of waste, the WOW technology, anaerobic gas lift reactor technology. I wanted to talk about the societal technology where waste is converted into around 23 plants are erected across India, and 4 plants are under construction. And Honorable Prime Minister mentioned this in Mann Ki Baat. These are all those things over here. And all these commercializations, I would like to tell you all that it generates a lot of employment, both skilled, semi-skilled, and unskilled. And that is how we contribute. So as an entrepreneur, you are not going to be an employment seeker. You will be an employment generator, an employment provider. So a lot of people come into picture when an enterprise or an entrepreneurial avenue is coming into a being. You will be creating a platform for so many people to be employed, and their livelihoods are being helped by you. So you should be really motivated to be an entrepreneur. And some of these successful recent entrepreneurs in science, in energy and healthcare, I just took it from the Google for you. Divya Nag, I believe, has started a StartX, and now she has joined the Apple's health team. So these are people who can inspire you. And Leaf Wearables by Pranjal Mehta, healthcare wearables was her field. And she has come up with creating a wearable technology for personal safety. It's called as Safer, flagship product had come into for locating, tracking, and emergency response. For on real time. This was very, very important for those people who were compromised for their safety. We have heard several of the girls who have been, victims of such kind of exploitation by unwanted people, and that can be evaded through this kind of innovation. And in sustainable energy, if you see electrical vehicles, this is coming as clean vehicles which do not pollute. All of us are suffering from air pollution, and we are again now wearing masks. Not only for the virus to be stopped, but also to stop the pollutants from entering into our respiratory tract. So electric vehicles is a very good innovation by Swapnil Jain, who is into development and manufacturing of these electric vehicles and energy storage solutions. So that is in electric mobility sector. Solar energy solution is by Sunroof, by Rohit Nayak, and he came up with end-to-end solar energy solutions. Adarsh Das came up with a renewable energy solution. He's the CEO and co-founder of SunSource Energy, and his company focuses on providing solar energy solutions. So from basically contributing to renewable energy, that's what our director was saying about biomass converting into energy. That's what is renewable energy. So students, I am really, really honored to have had your time to listen to me. So science, technology, innovation is plays a very crucial role in an entrepreneur's life, I would say, not only in their life, but also in the common man's life and the planet. So if you can come up with an innovation that distinguishes, that is what actually innovation distinguishes between a leader and a follower. And this is told by Steve Jobs. So students, I would say that innovation is not just about creating new things, but it is about solving problems and making the world a better place. And I'm sure you are going to be the future entrepreneurs, and your enterprises are going to make the world a better place to live. Thank you all for your patience, patient listening. And this is where I can be contacted, and you are most welcome with any questions in future. Thank you. Over to you, HRDG.
Thank you so much, ma'am, for giving us an overview on the entrepreneurship and innovation. And I'm pretty sure that the students will get helped by a lecture in becoming the future entrepreneurs. Thank you so much, ma'am.
Thank you.
So now I would like to invite our third speaker, Dr. Anshu Bhardwaj, Principal Scientist, CSIR Institute of Microbial Technology, MTech, to talk about the second theme of Epic Hackathon, that is One Health. Ma'am obtained her PhD from Center for Cellular and Molecular Biology, Hyderabad. She was a lead PI in the open source drug discovery project, where she conceived, designed, and implemented crowdsourcing as a tool to tackle challenging scientific problems, which is considered futuristic approach to drive big data scientific projects. Over the years, she has published several prediction methods, databases, and ontology-based barcoding methods for genome variation data towards better understanding of genotype-phenotype correlations, in addition to state-of-the-art interactome and reactome for Mycobacterium tuberculosis. She also served as an associate scientific advisor to Science Translational Medicine. She was selected as one of the young innovator in India by UNDP and for International Visitor Leadership Program by US State Department. Over to you, ma'am.
Thank you for the nice introduction. Let me know if I'm audible and if my slides are visible.
Yes, ma'am.
All right. So let's get started. And the previous speakers had made the life easy because now you know what the program is and what all encompasses it. So what we will discuss now is what is the domain of One Health in this EPIC program means. So what I have done for ease of understanding, I have divided the presentation into three parts. First is let's understand what the problem that we are dealing with. And that will feed into what is the EPIC challenge all about under the One Health umbrella. And very briefly towards the end, we'll actually share with you what we do in our lab. Now, since One Health, you all might have already guessed what the problem is. So the problem deals with human health and the treatment options. Now, one of the most important treatment lines in case of human diseases are antibiotics. We all know what antibiotics are. They are very important therapeutic agents that allow us to treat bacterial infections. In addition, they also facilitate life-saving interventions like organ transplants, surgeries, chemotherapies. This indicates that antibiotics are actually the foundation of the healthcare system. Now, one thing that we must remember is that antibiotics are not only used for treating infections in human, but they are also used for treating infections in animals, and hence heavily used in the animal husbandry as well as in agriculture. So the problem, where is the problem? So the problem is that we are not dealing with a single type of infection, and each infection is caused by more than one bacteria. Like let's say, for example, I have listed a few pathogenic ones here, and there are many more. I have listed only a few ones here. And given that there are so many varieties of infection and so many different types of bacteria, we need a very large repertoire of antibiotics to treat them. And this is where you see that there are different classes of antibiotics listed here. Despite the fact that in last 80 to 100 years, we have discovered a very large repertoire of antibiotics, The problem that we are facing for past few years is that most of these antibiotics have stopped working. So what do we mean by that? Now assume that there is an infection site and these are all the bacteria shown in silver and golden color. Now in order to treat this infection, what we do, we take antibiotics. When we take antibiotics, what will happen is, in this case, all the silver ones are dying. It is because they are responding to antibiotics. However, the one golden one was resistant to this antibiotic and hence it will proliferate further. So this clearly is indicating the point that by giving antibiotics, we are actually doing selection of resistant organisms. And that is why one needs to be very careful in using antibiotics. We should use the right antibiotic and we should use the right dosage of antibiotics. Now you will come up with an argument that, okay, this bacteria is not dying because of the X antibiotic is not working. Try Y. So we are actually, designing and developing newer antibiotics as the time passed. But one has to remember that antimicrobial resistance is an evolutionary phenomenon. Bacteria are learning for over 1 billion years how to fight these attacks because they have been surviving in each other in a similar scenario in a natural environmental setting. Most of our antibiotics are of natural origin. So the issue is that we now know that this arms race, the chemical warfare, is going on for so long that the bacteria are basically they are very efficient in finding mechanisms to evade the impact of antibiotics. How big is this problem? I'm telling you that, we take antibiotics to treat infections, and to be honest, it has saved millions of lives in past 100 years. But now the problem we are facing is these antibiotics, most of them are really not working the way they should. We are seeing a problem in terms of that even simple infections cannot be treated by antibiotics and people are dying because of these infections. To give you some data in numbers, the recent data that we found on the deaths caused by AMR, approximately 5 million people died of illnesses related to AMR, of which 1.3 are direct result of why some of these pathogens not responding to antibiotics. Put together, the drug-resistant infections are killing more people than HIV/AIDS or malaria in the world. And in next 25 years, it is predicted that Asia will experience approximately 4.7 million deaths directly by AMR. So you know where we are going. We are going into a pre-antibiotic area where when there were no antibiotics, people were dying because of infections. But even if the antibiotics are not working, the outcome is going to remain the same. And AMR is going to be one of the biggest health challenges that the human beings are facing today. And it is only going to go worse in future if we don't act on it. This is the reason that the World Health Organization has declared antimicrobial resistance as one of the top 10 global public health threats facing humanity. And this is the basis of our EPIC challenge. Antimicrobial resistance, which is also considered to be a silent pandemic, because I showed you data and I'm pretty sure most of you might not have heard about it because we talk of cancer, we talk of COVID, but we don't talk of antimicrobial resistance, which are bacterial, fungal and other forms of infections, which are spreading and are not treatable. The problem of AMR intensifies because of this. I would like you to focus on this diagram. So if you see here, this is the section where we are talking of pharmaceutical compounds or antibiotics prescribed for human or animal use. Now this waste or the excreta goes to wastewater. Through sewage plant, it can actually go to the sludge and it can go to farms. Likewise, intensive animal husbandry, there also a lot of antibiotics are prescribed. And remember this, the antibiotics in animal husbandry or in agriculture are not only prescribed for therapeutic reasons, they are prescribed as growth promoters. So what is happening is we want very fat chicken or very fat fish. So we are trying to make sure that in aqua farming or in animal husbandry, we are actually using a lot of these antibiotics as growth promoters as well. every red dot you see on these human beings or the fish or chicken, these are all they are actually reflecting either an antibiotic residue or a pathogen which is not responding to antibiotics. And now this actually makes it very clear that what is happening is even when the resistance is occurring in human, it is transmitting to aquatic forms in soil, in agriculture, to wildlife. And if it is done in animal or aquaculture or in agriculture, it's again moving around in the ecosystem. So the problem is more intense, and in most cases, we don't understand the source of where it all starts. And this is the challenge that we are dealing with. Can we identify the source? Can we trace the movement of antibiotic residues as well as antibiotic resistant pathogens in this ecosystem? So in our globally connected world, you can imagine this is not now a local problem. Now this is a global issue because we are also doing a lot of travel and we are, exchanging a lot of living and non-living material. So resistance to antimicrobials may spread and circulate among humans, animals, plants, and environment. And this is what the One Health approach is about. The One Health approach says that you cannot solve only antibiotic problem in the human population, but one has to look at the entire ecosystem to have a solution. Now, when I tell you that there is evidence to show that antibiotics, move from one form to the other, what is the evidence to that? So the evidence to that comes from the strategy that, we need a more integrated approach. So say, for example, One Health means that you need to make sure that the health of people, animals, and ecosystems are taken care of in synchronization, because sustainable human health is only possible if the ecosystems remain healthy. We cannot just make sure that we have antibiotics for us and we control and, it solves the problem. It is not going to solve the problem. The health of human, domestic and wild animals, plants, and the wider ecosystem are closely linked. And this is the issue that we are talking about in the EPIC challenge. Now, as I was telling you, what is the evidence we have? So there are studies where they have identified that antibiotics have been found in milk, meat, and honey. And why does this happen? Because one has to realize the economics of it. Now, animal husbandry and agriculture sector employs over 70% of the India's population, right? And the reason why there is so much of employment there, because we have a growing population and there is growing demand for milk, eggs, meat. And that is actually leads to an increased use of antibiotics as growth promoters. And studies have shown the antibiotic residues as well as antibiotic resistant microbes in these food items. So basically, the animal sourced food carry this antibiotics. And what is happening when we consume them? We are exposing our bodies to sublethal concentration of antibiotic doses, not killing the pathogens, but exposing them. So now they know what's coming and then they evolve to overcome that impact. Similar, observations have also been made from the environment. So if you look at river or wastewater treatment plants, a large number of antibiotics has also been, observed there. But the problem one has to also recognize here is that of all the studies conducted in India, less than 5% studies focus on the issue of AMR in environment. Now that is very surprising because environment contributes in terms of, spreading the antibiotic resistant bacteria as well as the residues across several verticals. And I'll show that to you. So there are environmental complexities in transmission and spread of AMR. If you look at this diagram, the environment, soil, and water. And I would request all of you to take a look at this United Nations Environment Program document, which very clearly describes what could be the potential sources of transmission of AMR when you talk of the environment, when you talk of soil and water, and how does the intervention of humans, wildlife, and the other things that we do in terms of livestock is influencing these movements. Because as of today, we have isolated observations, very few studies trying to say which pathogens are moving across different ecosystems and which antibiotic residues are being found in such ecosystems. There is no direct correlation so far. So there is a long way to go before we start doing a real-time monitoring of this context. And as you can really imagine, this can be a very geography-specific problem. So one has to develop platforms that is capable of documenting and tracking this data across different geographies. Now, as I was telling you, what is the impact on human life because of this? This is just one of the data sets. So to treat a drug-resistant bacterial infection, it normally costs around $700, which is more than 1 year of work for for a male casual worker in India. One also has to remember that in lower middle income countries, 25 to 70% of total income of a family goes in healthcare, which is just second to the largest family cost after food. So this is not just a problem in terms of, that we are falling sick and other things. It's an economic burden to the society. And this leads to a sick society. So if we are not healthy, we will not deliver on a very large number of things, not just, so remaining healthy is important. And as the previous speaker was also pointing to the fact that there has to be sustainable solutions. So I would like to also inform you that antimicrobial resistance is a sustainable development issue. Because even if you talk of poverty, zero hunger, good health, quality education, gender equality, AMR has been shown to impact almost all SDGs. And that is why in India's G20 presidency, One Health and antimicrobial resistance became one of the most important agendas to discuss, in the sense that what as a nation, as the whole world, we should do to find quick solutions and sustainable solutions at the same time. And this actually formed the basis of the domain 2, the One Health issue. I will not be telling you the exact questions you're solving, but I'll give you some ideas in terms of what are we expecting from the people addressing the One Health challenge. So let's start by, looking at a few of the innovations that might address the One Health problem. Now, one of the first things is we need to develop platforms to track antibiotic consumption in various sectors. It is not that government and other agencies are not doing it, but they only have presence in a few geographic locations. So you are not really getting, a real-time monitoring or tracking of prevalence of antimicrobial consumption. Talking of human health vertical, we would be interested to know how do we monitor or track prevalence of self-medication in humans, because in India, it is estimated, again, it's an estimate based on certain studies, is that 73% prescription-only drugs that you cannot get without a doctor's prescription are available over the counter. They are not supposed to be. And they are actually also prescribed sometimes by informal providers, which means they are actually not recommended to use under appropriate medical supervision. Now, this is a problem. So self-medication practice poses a substantial risk towards AMR. But in order to make sure that why this happens and who are the major, players in this self-medication pipeline, we don't know how to intervene because we don't know where the problem is more and what are the reasons for that and how do we track it. In context of animal health, we need to know what kind of prescriptions are being made in the animal sector. As far as I'm aware, there is lack of national surveillance system to monitor antibiotic consumption in the veterinary sector. So we don't even know what is being prescribed and how much for how long. And scarcity of this data limits our ability to differentiate whether the antibiotic was prescribed for treating infections, therapeutics, or to promote, as a growth promoting agent. So we don't know this data. This is all very ballpark figures that you get, but you really need data in a very geography specific fashion to make interventions. Likewise, in the food sector, to the best of my knowledge, there is absolutely no surveillance system in this sector. And we need to identify antibiotic residues and antibiotic resistant bacteria in the food. Can we do that? Can we are having a burger somewhere and somebody comes up with a device that allows you to monitor this in more real time? So, we need to empower the community. If we empower the community, the solutions will scale. And then people will start taking care of themselves. And that is also one way of keeping track of the quality of what we eat every day. Now, there are several initiatives like the mobile testing laboratory, food testing laboratories, food safety on wheels, Eat Right India. A lot of agencies have, the agencies have launched these initiatives, but still there is a lack of systematic surveillance system in this sector. The last one is environment. And of course, we know that there is a lack of surveillance system for monitoring antibiotic residues in rivers, lakes, soil, and including antibiotic residues from industrial effluents. There are studies, but again, coming from one or two sites. We really don't have a national picture of where are we going. Until the time we have platforms and methods and devices to track this, the intervention becomes an issue. We don't know what to do. We don't know how bad the problem is. And if the problem is bad in certain sectors more than the others, you know where to invest more. What other innovations we need? Likewise, we need to develop platforms to track infection types and their status in various sectors. What are the most common human health problems in a very geography specific manner? Likewise, animal health, likewise, food sector, environment. So we need to, so what we are recommending is if the community can come up with solutions which are either platforms or apps for collecting and using the data from community settings, from context of AMR, it would really help, taking these taking it to the next level in terms of solving this problem to some extent. Then we build applications for the environmental sectors for understanding AMR aspects like disposal, how antibiotics are disposed by communities. Hospitals know how to dispose antibiotics, but most of us don't do. Can we develop applications to help us understand that? And that is where brings to the fact that can we develop applications, prototypes, devices and methods for integration of data on disease prevalence in a community setting. What happens in a community setting? When I say community, I'm saying what is not hospital, out there in your house, in your colonies, in your schools. So the catch is how do we make sure that we have data in that context? So that is what comprises a One Health approach. Now, what happens if we don't solve these problems? So the absence of comprehensive surveillance data actually does a lot of damage. First, since we don't know what we are treating, there is inappropriate clinical decision making. There are lack of informed choices. Like, nobody really waits for an antibiotic susceptibility test to come. The antibiotics are already prescribed. So if we have appropriate surveillance data, at least you know what kind of infections are prevalent, what kind of AMR status is prevalent in that geography, and the damages can be, limited. Right now, it is all very random. And that is what is required to formulate effective health policies and responses to health emergencies. We actually, all of us lived through a very big health emergency, COVID-19, right? And we were not prepared for it. And you saw what that did to human life at a very large scale. Evaluation of control measures, both within healthcare facilities and broader community. If we know what kind of control measures are required in veterinary sector, what is required in the healthcare facilities, what is required in the community setting, we can actually identify and solve the problem. So the need of the hour is a comprehensive surveillance system spanning One Health, and we need to promote sustainable healthcare practices in the same set. Now, what other innovations are we recommending? So now this is the challenge, right? So find solutions. Can we identify incentives for clinicians, farmers, manufacturers, informal providers towards judicious manufacturing, use and disposal of antibiotics? See, if I tell you do this and there is no incentive for you to, because you don't understand the problem, you don't know what it can lead to, and you're looking at short-term benefits, then you might not be incentivized to, work towards solving it. So can we identify incentives for all of these people to work towards a common solution? Can we build innovative platforms for generating awareness? Because it has been shown that lack of awareness among various case stakeholders regarding proper antibiotic use is what is leading to, non-judicious use of antibiotics. So that's a problem. Can we inform stakeholders about various ongoing initiatives? I told you about a few initiatives in the food sector, but people don't know about them. Can we inform the wider community about these initiatives for wider adoption and implementation? Because sometimes the initiative might be launched, but without understanding the ground reality. So those gaps can then be bridged in terms of what really practically works and where the policy intervention has been made. What can we do to improvise it so that, it synchronizes well with the local communities, both at the local and the national level. So that pretty much basically on the front of what I develop, how can you develop platforms and applications? The other thing that we have also written in the challenge is how do we develop affordable point of care devices for diagnostics in rural and remote setup? Now, there is one example which I think will fit this description very well, and I'm going to play that video for you. So take a look at it, and these are the kind of solutions one would like to think about. So here's a video, and let me know if you can get to see the video and the audio both.
You hear that? That is the sound of a groundbreaking scientific device. It's called a paperfuge. That's a centrifuge made of paper. And like a traditional centrifuge, it works by separating the contents of biological samples by spinning really, really fast. That's an important first step for diagnosing illnesses like malaria and HIV. Manu Prakash is a bioengineer at Stanford, where he spends a lot of time thinking about how to make science affordable and accessible.
So to me, frugal science is really designing with constraints in mind. When we see bringing tools to the masses, we truly do mean billions of people on the planet.
Commercial centrifuges are heavy. You need electricity to power them, and they can cost thousands of dollars. In a lot of places in the world, you can't power, afford, or transport a traditional centrifuge.
And we told ourselves we're going to design one, but it cannot require any electricity because of the places we work in. It needs to be completely light and portable, that I could carry it in my pocket. And it had to cost less than $1 in parts, just so we could actually scale the manufacturing. By boxing ourselves in with constraints, we can think outside the box.
Health workers can load a blood sample and with very little force, power the paperfuge by hand.
I have a simple glass capillary with some beads in glass in water. And I'm going to take this capillary and put it right here. And at this point, I'm just going to spin this. And if this was a blood sample and I would spin it roughly at the speed for, say, a minute, I should be able to get the entire contents of that blood, all the RBC, separate out from the plasma. So here is the capillary, and all the beads are all the way in a really, really narrow band up here, and then the completely empty fluid is right on top.
Paperfuge is based on a classic toy called a whirligig. The design has been around for thousands of years, but it wasn't until very recently that anyone developed a physical model for how it works.
Yeah, so you do realize what kind of solutions one can develop with, by understanding the problem very, very clearly, and then trying to develop solutions which really scale at point of care, right? So this is just to give you an idea in terms of what one can develop. The rules of, the creative submission and the general rules and regulation for all submissions are listed here, and the entire team of Jigyasa is here to help you out in terms of if you have questions, we are there to answer them. Now, moving to the last part of my talk, I'll be taking only a few minutes. What do we do in the lab? And I just wanted to give you ideas in terms of what, we offer in terms of expertise. But Intech actually has much wider expertise. I'll come to that. So I would like to start by showing what Sir Alexander Fleming said in his Nobel Prize speech. So we all know that he shared the Nobel Prize with Ernst Chain and Sir Howard Florey for his discovery of penicillin, which is the first naturally acting antibiotic. And way back in 1945, he was warning the scientific community, saying that if we expose, microbes to concentrations which are not sufficient to kill them, they might start showing resistant to this antibiotic, right? And this is actually true. So he recognized this fact in 1945. So the point is, what doesn't kill you makes you stronger. And since we know that AMR is an evolutionary phenomenon, year by year, there is an evolution of different strains. And when humans continue to abuse and overuse antibiotics, what happens? They keep on mutating and getting better at dealing with newer antibiotics and newer forms of treatment that we are recommending. So one thing for sure is that what we have today and what is working, which antibiotics are working, we need to make sure that they are used to the best possible manner. How do we do that? There are issues in terms of how do you convince everybody that don't take antibiotics if they're not required, don't take antibiotics for viral infections because they don't treat viral infections. How do you make sure that the clinicians are not prescribing antibiotics when they're not supposed to? So the problem is that what should we do for better engagement and understanding of the problem itself first? And the reason why we have to do this, because several studies done like a couple of years ago by WHO, then subsequently published last year or a year before that, they are pointing to the fact that there is need to increase public awareness to better understand AMR. Because if whatever innovation you do, and if people don't use it properly, that's not going to really work. And there, people need to fully understand what causes AMR and what they can do about it. And that is where we have been running an open antimicrobial resistance awareness drive. We use technology as our tool to make sure that we, do a lot of science as well as science outreach to generate awareness on AMR. Now, one of the things that we also realized that it should be the young children that should be understanding this problem better than the adults, because you are the future of tomorrow. That's one thing. Second, if you understand the problem now, it is easier for you to educate your parents and your communities where you stay in your schools about the problem of antimicrobial resistance and can really bring a change. You can be the driver and the champions of these innovations. And that is why we thought that our target audience for this kind of interventions should be young school children ranging the age of 12 to 17 years old. And that is why we thought what would excite the younger generation. And that is when we came up with this idea of why not develop a video game? You already have too much homework. There is so much study that you do. So we thought, let's develop something which is easier to follow and more fun. So you learn as you play the game. So instead of playing the game here, what I'm going to do is I'm going to run a very small teaser of the game. You get an idea and then we'll move forward. Right? So here we go. Right. So, given the importance of such innovative technologies for addressing AMR, the World Health Organization in India has endorsed this game. And what we also understand, I'm a gamer as well, so I know that I'm not going to come back to a game if I don't have multiple levels and challenges to solve. So it's a multi-level game. And since we also want to convey the message of why you have won or lost a level. There is, with each level, there is an introduction screen of what you are challenged with. Then if you lose the level, it will tell you what you really have not done correctly. But even if you win a level, it's going to tell you what you have done correctly. It's like a positive reinforcement strategy where we are trying to positively reinforce your thought process in terms of, oh, this was the right strategy to address AMR. Now, as I told you, it's a multiple level game. There are certain levels which are skin infections, then lung infections. And I'm happy to inform you that the International Academy of Engineering has offered us a grant to convert Armor into a multiplayer game. So that is something that we are on to now. It's a single player game so far, but you will very soon see a multiplayer version of it. This version was one of the 5 finalists in the International Educational Games competition. So that's one good thing. Now, since everybody is not a gamer, but we still want to make sure that the community is informed about the issues of AMR, We are doing a web series on microbiology, infection, and AMR, and these videos are available through the Jigyasa platform. We also go and work with a lot of school children. We adopted schools in and around Chandigarh, and we do experiments with them on microbial diversity, experiments to understand hygiene, and the basic concepts of the science behind antimicrobial resistance. Apart from all these outreach, we do a very large number of projects in the lab to solve the problem of antimicrobial resistance, to understand the problem of antimicrobial resistance in a very, very scientific manner. I'm not going to describe those methods to you. Some of them are published, some of them are in the process of getting published. I would like the students who are interested to know the science behind it to take a look at these resources. Very recently, we have also published a strain. So what we did is we actually went to a crowded market in Chandigarh and did air sampling. In that air sample, we identified MDR, like a multiple drug resistant Asterobacter baumannii. We yet don't know if it is a clinical isolate, if it's an environmental isolate, because the genome doesn't really clearly indicate where it belongs. But the issue is that since it is out there, the isolate definitely has a possibility of spreading AMR genes, because it actually has a lot of them, as you can see from the graph here. So it actually is, and it's a very diverse strain. It doesn't look like what you'd normally see in the clinical isolates or globally. So it looks like a very diverse strain. So we are actually trying to extend the study further to see what do you see in the environment and clinical settings and elsewhere. So before we conclude, since we all are there in the presentation today, this is normally I do as a standard practice, is that we should take a pledge. And why this pledge is important, it is not just solving problems for the other, it is solving problem for yourself. We all are party to this issue. We know when things go wrong, it doesn't go wrong for scientists versus non-scientists or doctors versus non-doctors. Everybody becomes a part of the problem. So that is why everybody should also become part of the solution. And one of the easiest solution is, if we take a pledge of not taking antibiotics if not prescribed by a doctor, we should only take as much as prescribed. We should always consult a physician before taking any medication, not just antibiotics. We should never take antibiotic for a viral infection like cold or flu. And if somebody else is sick in your house and you also are sick at the same time, don't assume it's the same infection, and don't take antibiotics prescribed for someone else or vice versa. And most importantly, prevention is better than cure. So if you eat healthy and maintain a good personal and environmental hygiene, it'll help you to avoid infection and stay healthy. Staying healthy is the message, and making sure that you don't fall sick. And even if you do, make sure you think like a scientist and do all your evidence-based analysis to make sure what you're taking is what you need. So with that, I would really like to thank all the funding agencies and lab members who actually work with me on a, in India and in France, to make sure that we are able to do and contribute something in this domain. In the end, I would like to really provide this feedback to school kids. I work with a lot of undergrads and school children in my lab, and they have been, my experience with school kids is extremely rewarding. So if you think you are not ready to do science, I don't believe it, because there is evidence to show that you are. Some of the evidence was shown to you by the previous speakers also. So it's not the age or your degree that is going to define what you're going to do. It's your passion. If you want to solve something, if you want to contribute, there is no age, there is no degree that will stop you from doing that. And in anything that requires translation, as your previous speaker was saying, all the CSIR labs are at your disposal. If we collectively work, so you come up with ideas, we'll together build a solution for a better, healthy world. And with that, I would like to wish you all the best, and we are available to answer all the questions that you have going forward. Thank you so much.
Thank you so much, ma'am, for giving us an overview and insight about the AMR and One Health. If there are any queries from student side, or if they want to connect to you, we'll reach out to you, ma'am. Thank you so much, ma'am. Now, to conclude the session, I would like to call upon Mr. K. Sridhar, Principal Scientist and Scientist in Charge, Jigyasa Program. Please.
Yeah, thank you, Raina. So on behalf of CSIR JIGYASA team, first and foremost, the panelist, Dr. Ramesha, Director CSIR Secretary, Dr. Shailaja, Chief Scientist and Chair Business Development, CSIR ICT, Dr. Partha, Principal Scientist, CSIR IITR, Dr. Anshu Bharadwaj, Principal Scientist, CSIR Intech, all for giving an enlightening talk. And to start with, I thank Dr. Partha for introducing about JIGYASA program and also about the EPIC program. In fact, he had started this EPIC program at CSIR IITR, and from 2017 till date, he has been running it successfully. So we have taken lead from him, and he has been handholding and helping us out in this program. So thanks a lot to Dr. Partha for this. We thank Dr. Ramesha, Director CSIR Secretary, for briefing us about the energy sector, especially clean and green energy. Your talk on energy provided by sun for 1 hour is enough to address 1 year energy demand if stored properly, was an eye-opener to all of us. And also I understand, I'm sure that students would have taken note of your stress on passion and commitment, fruit battery, primary, secondary battery, fuel cell, hydrogen cell, biomass, etc. were exciting and much needed for students. And also your closing remarks, improving the existing technologies, breakthrough, out-of-box thinking are the main objective of this hackathon. And thank you very much, sir, for covering all this topic and giving us a crisp and very important talk. Thank you, sir. The next talk was by Shailaja ma'am. Her talk on entrepreneurship and how a successful entrepreneur can be, what are the ingredients for to be a successful entrepreneur. Students were very much, briefed about how to take entrepreneurship, and also her example about the Wi-Fi scenario was very, I think it connected with the students very well, because it is a very contemporary example and students can correlate with the present day scenario. Thank you very much, ma'am, for giving us a comprehensive talk on invention to innovation. And also you had stressed on collaboration and creativity. And to finally summarize your quote on an enterprise may fail, but an entrepreneur will never fail. Summarized your talk, ma'am. Thank you very much. Finally, we had talk by Dr. Anshu. Her talk on One Health was focused on antibiotics and what are their uses, and her game on antimicrobial resistance and the entire One Health, how One Health can be connected with antimicrobial research was totally a eye-opener for everyone. I believe students might have learned a lot from all the talk, and thank you all the speakers for your enlightening talk and giving us a complete overview of the program. Finally, I thank my JIGYASA noodles who had participated in this bootcamp online and also organized student participation. I also thank my key stakeholders, all the school children and teachers who have joined online through various laboratories and also through the YouTube channels. We had more than 300 people who had participated. I thank Head HRDG for steering this program and giving us a vision and direction. And finally, I thank my team, Mrs. Raina and Mr. Tarun Garg, who have been coordinating the entire program. Ms. Raina for anchoring the program and Mr. Tarun Garg for sitting behind the screen and managing the entire show. Thank you all. Thank you for this boot camp. See you.